Hello Year 12 chemists, welcome to TP's Chemistry Cuts. In this clip we work through an example of a mass-to-mass calculation.
So let's go through what a mass-to-mass involves. Now we're given the mass of one substance in a reaction, and we've got to calculate another one, an unknown. And we can do that because we can convert a mass into a number of moles, and then we can use the equation for that reaction to see what the ratio of moles in the equation between the known and the unknown is, and using that ratio or relationship we can then transfer the number of moles, or we can convert the number of moles of known to the number of moles of the unknown, and once we know the number of moles of the unknown we can then calculate its mass. And remember, you will be given this formula, so if you've forgotten it, then it is given to you, and I'd recommend you write that at the top of the paper along with its rearranged form where you've got m equals n times m, because you're going to need it, because you're going to actually calculate the mass of the unknown at the end. Okay? So everything you'll need is given to you, so it's a good idea to highlight the things that you have been given. Okay? So this is the mass of the known, okay, and that's identifying the known. So the known is this one. You're being asked to calculate the mass of hydrogen, so that's the unknown. So it's probably, for those of you that struggle with the algebra and so on, a good idea to label them clearly. Use a pencil or something on the paper, that's quite all right. Okay? Now, as before with a titration, this is very analogous to a titration. You're just using that equation rather than C equals N over V, but you're following the same steps. Okay? And the critical thing is relating the known to the unknown. So what we did with the titration is to put together a little table to begin with, to make sure we don't mess things up. Okay? So we've got our known and unknown, known and unknown. Okay, let's identify them first. So the known is NH3, so the unknown is H2. Okay, the mass of the known is 13.5 grams. We don't know what the mass of hydrogen is, that's the whole point of the exercise, but we've got the molar mass of NH3, which is 17.0 grams per mole, and for hydrogen it's 2.00 grams per mole. Just a quick word about that. Remember, the molar mass relates to the mass of the particle, and because we're dealing with hydrogen gas, which is a diatomic molecule, then we have 2 times hydrogen, not 1. So we're not dealing with an atomic mass, we're dealing with the molar mass of the molecule of hydrogen. Okay? So that's our starting point, and for our known substance we have a mass and a molar mass. So the first thing we can do very quickly is to calculate the number of moles. So we can turn the mass into the number of moles using this equation here. Now I'm going to write this out all in full, so if you want to go through this again, then you'll have all the details. You don't necessarily need to write out every single time you do a thing like this, each step. Okay, so just to make that clear. So the first thing is to calculate the known amount. And we use N equals little m over big M. So we've got our known substance from our table is N of NH3 is equal to the little m over the big M, and our little m is 13.5 over 17, and that's equal to, if I need somebody, 0.794 mole. Okay? Now we have that, we can now relate that to the unknown using the mole ratios of the equation, the balanced equation. Okay, so relate known to unknown using mole ratios of the equation. Okay, so n unknown divided by n known, which is our mole ratio. Our unknown is hydrogen, which is 3, and we're dividing it by 2 for the known, which is ammonia. So if we rearrange that, just move the known up here, then n unknown is equal to 3 over 2 times n known. And it's in situations like this, it really is best to do it this way, because it's so easy to get that the wrong way up, especially when you're doing some odd sort of ratio. Okay, so n of our unknown, which is H2, is equal to 3 over 2 times n of NH3, which is equal to 3 over 2 times 0.794, which is equal to, anyone? Sorry? 1.19 mole. Okay? Now we've got that, we can calculate the unknown mass. So we've got the rearranged version up there, which is m times big M. So m of H2 is equal to the number of moles, which is 1.19 times. Okay. So it's times the molar mass of hydrogen, which we've got up there as 2.0. So that is 2.38 grams. Okay, and remember it's me that's marking this and I know nothing, so you need to tell me that's 3 significant figures. So our equation's over here, then we calculate the known amount, re-relate it to the unknown, then we calculate the unknown mass, and at the end we've got the significant figures. So you've got 4 or 5 steps that are involved in calculating an unknown mass.